Hello there. Looks like we are live. So today we are going to talk about AI voice agent. So it was requested. We got a lot of requests about this webinar about AI voice agent, conversational AI agent, AI telephony agent. So we are going to discuss some relevant use case in this webinar. And today we have Ankit with us. So first, let's wait for a few seconds to for other participant to join in. So so far we have Razveer, Alex. Welcome. Oh, Varun. Welcome. Hi. So we have Ankit with us. Hi, Ankit.
Hey Sumit, hi, how are you?
I'm good. So Ankit, so we have Ankit with us. So Ankit implemented Python SDK. So with the help of Python SDK, we can implement AI voice agent. So Ankit, would you like to explain more about Python SDK? So Python client we implemented.
Yeah, sure, Sumit. So basically, our Python SDK is a server-side implementation of the video SDK. And within a Python SDK, you can do a lot of AI stuff, be it AI translator or be it AI proctoring for interview preparations, or be it face landmark detection, face detection, or vision AI. Anything related to AI and ML, we can do within Python SDK.
Yeah, perfect. So in this web uh, translation application. So I think my mic was off. Sorry for that. So what I was saying is in this webinar we are going to present one example which is AI translation agent. So how it work is we have like two participant. We have two human participants, so they speak different language, so they can talk to each other through AI voice agent. Okay, so let me start by sharing my screen. Is it visible?
Yes.
Perfect. Today we'll show you how you can build real-time AI voice agents using OpenAI speech-to-speech feature. So OpenAI provide a real-time API that we can use to implement real-time AI voice agent. So OpenAI provide like there are two options that we can choose. One is WebRTC and another is WebSocket. So WebSocket is mostly utilized on server side. So in this video, in this webinar, we are going to show the implementation of WebSocket. So aim of this webinar is to give you a better understanding of how you can add all the attributes to your AI voice agent, such as thinking, speaking, vision capability. So technical term for that are speech to text, text to speech, speech to speech. So in this webinar, we are focused on speech to speech. So let me quickly jump to today's agenda. So these are the topics that we are going to cover. So first, we are going to discuss conversational AI infrastructure. So like what are the things in the stack of conversational AI agent? Then we are going to discuss the architecture. So this architecture part will be explained by Ankit in more detail with code samples. Then we are going to talk about our voice agent examples, like what are the examples that we have implemented so far. And finally, we have this AI translation agent. So this is a specific example we chose for this webinar. And finally, we'll take questions from the audience. Okay, so next, so let's start with conversational AI agent. So this is the image I took from conversational AI report, which you can get from SoNote. So this was the architecture before May 24, where we were dependent on a lot of AI service like services that provide text to speech. We were dependent on other AI services someone who provide different LLMs, right? So this was the stack before May 24, and with introduction of speech to speech, all this stack is gone. Now we have application layer, voice to voice model that do everything for you, like audio processing, a conversion of one audio format to another audio format. So stuff like that, everything is handled using voice to voice model. Okay, so next, let's try to understand the architecture that we are going to discuss in this webinar. So we have this client application which is built using React SDK. So we provide different SDK for different platform. Similarly, we have Python SDK. Basically, that AI agent is just a participant. The thing with this AI agent is it doesn't have access to microphone. It doesn't have access to camera. So we have to create those stream, right? So that we can have an AI agent that can talk to us in real time, and based on that we can implement different use cases. So these are the examples that we have implemented so far. So initially we built voice agent where we used deepgram. Then we used a game agent where we were talking to an AI agent. Also that AI agent was playing game with us, so it was pretty unpredictable. Let's say I am playing a game with a bot, then it's not as interactive as it should be. So with AI game agent we can have a bot that can talk to us, that can play with us, that can recognize what are the actions that we took. Next, we built vision agent. So this is where we used OpenAI speech to speech, and also we built a translation agent. So this is what we are going to explain in this webinar. Okay, so that's all from me. If you are trying video SDK first time, so you'll get 10,000 free minutes every time. So, like if you don't know about this, we provide 10,000 free minutes every month. So you have enough time to explore our product. Next, I would like to invite Ankit. So Ankit, over to you.
Yeah, thank you so much, Sumit, for having me here.
Yeah.
Can you please stop your
Yeah,
submission?
just give me a...
Yeah, sure. So my screen is visible to you guys.
Yes, it's visible.
Wonderful. Yeah, thank you, Sumit. So Sumit have mentioned lot of use cases of AIML agent using Python SDK. So today in this live streaming session, we are going to create a AI translator agent using a video SDK for audio and video call. And on top of video SDK, we have also used OpenAI real-time API, which is a whole stack of LLM, STT, and TTS. So in this architecture, we have integrated video SDK and OpenAI real-time API to create AI translator agent. So let's quickly jump into the architectural view. So we have follow client server architecture basically. So in client side, we have used React SDK, and on the server side, we have used Python as a server side SDK. So in a client side SDK, first of all, we are gonna create a room using this API. You can find this API documentation from available documentation of the video SDK, which is a docs.videosdk.live. And you can go through API reference, and over here you can go on a REST API. So here you can create a room and available request body parameters, and you can also subscribe to available webhooks. Yeah, so this is we have used over here create for creating a room. And then we are going to start a session on a client side. We are going to connect a client to video SDK server via React SDK. And then last step was on the client side is invite an AI agent. We will invite an AI agent by using our API join agent, and we will pass two parameters, token and meeting ID. Let's quickly jump onto the server side. So we have used Python fast API server, and Python fast API server, we are serving one request. While serving request, we will start background task as a Python client SDK. So what basically happens over here is whenever request will incoming request, we will serve that request, and our bot from the server side will join to the client side SDK. So here is the architecture of a room. What will look like high level architecture. So while creating a room, we will first create a room, and then state management, which is handled by the SDK itself. On a state management, first of all, we have a client in a room, and then we will invite an AI agent. So there are two participants in the room, client and AI agent. So while doing Python SDK, we have a couple of things to remember: audio processing and OpenAI integrations. So audio processing is for while we are consuming client stream, audio and video streams. For audio and video stream, we are receiving these streams into the frame, AV module frame. Inside of Python, we have AV module, and we are using that frame. So to provide OpenAI integration, OpenAI will accept base64 audio encoded. So we have to convert that frame into the base64 encoding. So we are doing audio buffering on the server side, frame processing on the server side, and audio conversion on the server side. And while we are doing conversion as well as frame to base64 decode, we will pass this base64 encoded streams to the OpenAI integration by using real-time API connection, which is nothing but a WebSocket, audio transcription, which we will get from the OpenAI real-time APIs, and audio response handling. So yeah, this is it for the architectural overview, and I know you guys want to show the demo and want code as well. So let's quickly start with the code as well. So first of all, we are going to clone this repository, which is available on Video SDK community organization, and inside that Video SDK OpenAI real-time translator. Before cloning this repository, I would highly recommend to generate API key from Video SDK API key from app.videostk.live, and here over here API keys, and you can generate a token from here. I will suggest you to generate a 7 days of token. We will copy that token as well. And for the OpenAI real-time APIs, you will go onto the platform.openai.com and slash API keys, and here you can generate API key as well. I have already generated my API keys as well. So for the documentation part, I will recommend OpenAI official documentation for the real-time APIs, where you can go through the beautiful use cases and how to connect with WebRTC and how to connect with WebSockets. So we have in this live stream, we have focused more on the connect with WebSocket to our real-time APIs. For the video SDK documentation and the for reference on the Python side, I will highly recommend to go over at docs.videostk.live, and here you can inside the guide I will recommend to go to the Python, and here you will find all the examples and all the use cases of the Python example, and over API reference you will see the details of SDK and all available classes and all available events associated with the meetings. So let's quickly go through the code. We will first clone this repository using this command. So git clone, and then we will go through the directory. So on a client side setup, there is already one directory inside this repository, cd client. So for the reference, for the easy purpose, I will open this repository into the VS Code editor. So here we have VS Code open with the following repository. So over here, there is one directory called client. Let's quickly set up our remaining things. Yeah, so over here we have to go to the client directory, and then we will copy this environment by example into the environment.env file, which is nothing but to store our environment token of video SDK. So I already, let's quickly generate a new token for the same by going through app.videostk.live, and I will generate a token from here, 7 days of token, and here we will get the token of. Wonderful. So on the README file, you can see we have done this client side setup, and let's quickly jump onto the server side setup. So for the server side, we have used the Python. So we need to create one virtual environment. So we will create one virtual environment using Python 3. I will recommend Python 3.11, which is compatible for video sticker Python side client. I have created virtual environment successfully. Here you can see. I will quickly activate my virtual environment first by doing source env bin activate. We have activated our batch environment, and here we will install our remaining dependency for the server side, which is already mentioned in the requirement.txt file. We will quickly install all the dependency available for the requirement.txt. It will take 1 or 2 minutes of time based on the network. Okay, wonderful. So we have downloaded all the dependency for the Python side and our client side. Let's quickly go to the readme file as well. We will also create .env for the Python side, server side, I guess. So here we have environment example, and here we have to copy our OpenAI API key. So I have already copied from the platform.openai.com. You guys can also copy or generate API key from here. Wonderful. So I have done the client side setup as well as server side setup. I have also obtained API keys, and let's quickly run our client side application. Before going to run our client side application, let's go through the code so it will get more better idea to what is running on the client side and what is running on the server side. So I will follow. First of all, we will discuss about the client side application, and then we will move towards the server side Python SDK. On a client side, we have used React.js, and on top of React.js, we have used Video SDK for audio video calls. Inside the source directory, you can see there are components, meeting controls, and participant card. Meeting controls is used for okay, so I have to install npm as well, so it will release this error as well. Let's quickly go through the inside the client directory and npm I. Okay, wonderful. So you guys can see error is gone. So here meeting controls is used for mute a mic, unmute a mic, or invite an AI agent. Here you can see we have integrated invite AI by using this server-side API call join player. On the participant card, we have used participant card for to show the participant grid in the UI side. In the store, we are storing our video stick API token, which is available on environment file. In app.tsx, we have a meeting view, or here we have to consider our meeting provider, which is available from our React SDK. Here is our meeting provider. Inside the configuration of meeting provider, we have used meeting ID, mic enable or not. This is all from the client side, which is run on the browser side. Debugging mode, metadata, and token and join without interaction. For the meeting provider and meeting view components, I will highly recommend to go through the video SDK documentation for guidance using React SDK. Here you can find all the details and all the providers of all the hooks available on the meeting or all the associated events within React SDK. So I will highly recommend to go through the React SDK as well. Yeah, so this is a very easy and very clean setup on the client side. And let's quickly run the client so you guys can see client is running cool. Yeah, so here we can see that our UI is running perfect, which is built on React.js. And let's quickly move on to the server side, and then we will connect our client with the server. On a server side, we will follow through main.py file. In main.py, we have used fast API for API server, and inside of fast API, we have used background task to join a bot in client-side SDK meetings. So as I have already mentioned in the architecture, here you can see. So here we have done all the setup for the client side, and we are remaining setup for the Python side. And while both join the Python SDK, so it will look something like this. So, on the client side, we have room, and also client join on the room. and on the server side we will invite an AI agent. So inside the room there are two participants. One is client, which is our browser, and AI agent, which is our Python SDK. So why AI agent? Why AI agent is useful for to consume a stream of participants, available participants in the meeting. So let's quickly go through the server side setup. We have used Fast API, as I have already mentioned. Here you can see the join player API, which will run a background task, which is a server operation. Server operation is nothing but async method. Inside this, we have used AI agent. We have created one AI agent class object, and then we have joined this AI agent. So for this, we will go through some of the classes available on the Python side. First of all, first class is AI agent. AI agent is nothing but video SDK plus OpenAI integrations, and there are two more classes, which is OpenAI real-time APIs, and another one is custom audio track for the Python side code. So let's quickly go through the AI agent. AI agent is available on the AI agent here. Inside the AI agent class, we are doing Python side joining, Python SDK joining in the video SDK. So here AI agent, inside the constructor you can see meeting configurations available, which is the name of the bot, meeting ID, token, which is you can generate from the app.videosdk.live, mic enable or not, webcam enable or not, and custom audio track, which is our bot's audio track, which will help us to translate the incoming audio, and it will generate translated audio, which is coming from the OpenAI real-time API. There is a meeting handler, which will help us to do action on the associated meeting events, like on meeting join what we have to do, on meeting left what we have to do, on participant join or on participant left. There is also two more event attached to participant, which is a stream enable event and stream disable event. Stream enable is nothing but whenever we are muting or unmuting ourselves on the client side, we will get an event which is a stream enable audio or disable audio. So while doing this, we can ensure that the participant mic is on or not. So there is one more object, which is the intelligence, which is nothing but our OpenAI intelligence, which will connect our Python SDK to OpenAI real-time API using WebSocket. And then we are passing our audio frames to the OpenAI intelligence. And while OpenAI intelligence will translate new audio, and we will get audio, and we will pass that audio into the video SDK meeting. We will go through that code as well. So while let's see the couple of events which is associated with the meetings. First one is on meeting join. On meeting join, we are doing OpenAI connection, which is intelligence.connect, which will doing nothing but let's comment out here. Let's add a comment as well. So which will connect OpenAI WebSocket connection on meeting join. On participant join, we are doing nothing but we are maintaining one map with the participant name and the chosen language. So while on the UI side, you can see over here, let me show you UI as well. On the UI side, while creating a new meeting, we are also choosing one language and name. This is my name and this is my chosen language. So on the backend side, we are maintaining that map, which is the name of the participant and language of the selected participant. And here is our nothing but our system prompt, which is we have to provide to OpenAI real time. And then we are updating session instruction with new system prompt. So which is nothing but we are telling OpenAI that this participant is the participant name is Ankit and his chosen language is English. We are doing by update session instruction. Don't worry, we will go through the intelligence code as well. I have already told you that on participant join, we have another event associated with participant, which is stream enable and stream disable. On stream enable, whenever this participant will mute or unmute himself, we will get stream enable event, and we have added one condition over here. If stream.kind equal audio, that means if there is any audio, we will capture that audio and we will send it to over the OpenAI real-time API. On stream disable event, we will doing other things, like if stream.kind is equal audio, then we will canceling that task.
Uh,
Yeah, so is there
okay, so far, if anyone has any questions, please feel free to ask. Uh, So we discussed so far this AI agent, how it is joining. So on top, like we discussed, like what are the methods available to us, and then we were overwriting some events. So if anyone has any questions, they can ask. Uh, Gemini real time, yeah, definitely. We already have example for that. Yeah, you can use Gemini real time API as well. So do you have this solution for Node.js and React Native? So I think Ankit can explain that.
Yeah, what was the question?
So they are asking if, like, do you have this solution for Node.js as well? Like we created this Python client, right? Uh,
So my audio is audible to everyone, yes?
yeah, it is audible.
Yeah, okay. So yes, Tahil, it is available on the React Native side. You can use React Native, but on the Node side, we have not right now any WebRTC capture frame available, any methods to capture a frame or ingest or consume any participant streams right now. So right now, Node.js is not available.
So I think Harshit did some distillation as well. So he's asking, can we use distilled LLM for this?
Yeah, sure, we can use a distill LLM as well. But if distill LLM is real time,
Uh, do we have Java or Kotlin SDK?
yes, we do have Java and Kotlin SDK as well.
Okay. So now let's go with OpenAI intelligence. So how it is processing our audio, right?
Yeah. So far, we have seen the
Uh,
how to join a pod.
Someone is asking for MCP server. Okay.
Yeah, sure, Tahil. We will surely happy to connect MCP servers as well in this demo as well. So
Yeah.
right now it is not available in this demo, but we will surely make a demo with MCP server connection as well.
Yeah. Perfect. Okay. So let's move with.
So let's quickly dive into the OpenAI intelligence clients. So there is one another class OpenAI Intelligence, which is doing WebSocket connection with OpenAI. We are sending streams to OpenAI, and we are consuming stream from the OpenAI. While sending a stream and consuming a stream, we have to consider things which is OpenAI is accept only base64 encoded audio. So we have to send a stream in base64 encoded, and we have to consume a stream in base64 encoded. While uh, and then and our video SDK meeting or WebRTC is accept AV frame or AV module frame. So we have to convert that base 64 audio into the AV module, and we have to pass while passing the stream. We have to convert AV frame into the base 64 audio. So let's quickly understand the OpenAI intelligence class. So inside the constructor, you can see we have chosen a model. Which model we want to use? So here we have already used GPT-4 or real time event loop, API key for the API instruction, and here which is important, session update parameters. You can see the session update parameter from OpenAI real-time API documentation. Here we have added model, instruction of the model, input audio format. Here you can see we are passing PCM16 audio, and output audio format which is audio format PCM16. Temperature, voice tool, uh, I wanted to give you this is important because right now we are consuming audio stream on the Python side, which is Opus format, Opus encoder, and we have to pass that audio. We have to convert this Opus into the PCM16, and then we have to convert. We have to base 64 encode and then send it to the OpenAI. While receiving them, we will receive PCM16 audio bytes, and then we will convert it to the whatever our audio sample rates.
Yeah.
Yeah. So here is the voice of the bot, tool choice, which is not required right now. Turn detection is, yes, turn detection is needed. Modalities of the model, maximum response out time tokens, and input audio transcription, which is,
So these were like audio settings, right?
yes, exactly. This is the whole audio settings, and there are more parameters as well. You can see our documentation. Let me go through session with the parameters. So here you can see OpenAI real-time client events and then session update. So we have these updated parameters from here. So you can see over here modalities, instruction, voice. Great. So inside there is one method called async connect, which is connecting our Python server to OpenAI real-time. In this, we are using a WebSocket connection for the OpenAI real-time API. You can see how to connect OpenAI real-time by using this documentation, connect with WebSocket. Okay. There is one update session constructions. This method is we are calling on while participant join, and then we are telling OpenAI that this participant join and his chosen language is this. So this is nothing but while we are inside AI agent, we are updating our system prompt, and then we are updating our instructions. So this is nothing but our updating instruction to the OpenAI. We are nothing. This is nothing but we are telling OpenAI model that this participant has joined and this chosen language is this. Update session, send request, which is to communicate with OpenAI real-time API, send audio data. This is a receive message handler, which will help us to identify incoming messages from the OpenAI itself. So while consuming responses from the WebSocket, we have two types of messages. One is a text and another is error. If any error messages, then we are simply logging that error messages. And inside the text, we are passing that handle response. Handle response will identify that message types, which is available types of the messages are session created, session update, response audio delta, which is important. We will discuss this. Response audio transcription done, item input audio transcription completed, or input audio buffer speech started or not. So these all are event type you can check from the OpenAI real-time documentation as well. So here we have one important response message from OpenAI is response audio delta.
So basically, we get a response in form of transcript and deltas, right?
Yes, exactly.
Yeah.
Okay, so let's see the how we are sending over a stream our stream to the OpenAI and how we are consuming that OpenAI stream and passing to the video sticker meeting. Okay, so in AI agent class on stream enable here, if stream.kind equal audio, that means the participant has toggled that mic and unmute himself. Then we are calling this method add audio listener. Inside the add audio listener, let me comment add comment over here. This is useful for sending audio data to OpenAI. Cool. So inside this, we are getting frame from the stream, which is available using video sticker stream. You can go through the stream class from documentation.videosticker.live. Let me show you inside the API reference, inside the Python. Here we have a stream class, and stream class has a introduction. This property called track, which is nothing but our audio track.
So like we'll get all the three type of stream, right?
Yes, we will get all the three
Yeah.
types. It is audio, video, screen share, or screenshot audio.
Yeah. So like screens, we have different use cases for that. Like if it is a screen share, we can make use of some Vision API,
Yes,
right?
exactly. Yeah, in screen share you can use screen share. I think already you have.
Yeah.
Yeah. So inside the stream we have one property is called track, and then inside the track we have called method receive. This is nothing but it will get us a frame, which is in 20 millisecond we will get one frame. In 20 millisecond we will get a one frame, which is from WebRTC itself. And then this part is important because this is nothing but audio buffering and audio to convert into PCM frames. And then while we have PCM frames, we will send this PCM frame to the OpenAI client. So this is done for the sending audio data to how to send audio data to OpenAI real-time API. So we will get a frame, then we will convert that frame into the PCM frame itself, and then we will send it to our intelligence client. Inside the intelligence client, let me go through this method as well. Send audio data. So we are, as I have already mentioned you about OpenAI will accept base 64 audio data. So we are incoming bytes we have converted into the base 64 audio data, and then we have created one message. This is nothing but our type data type itself we have created, and this is a message we will send over to the send request. Send request is nothing but a WebSocket message send. So this is done for the outgoing part. We will send incoming stream of the participant, and then we will send over to the OpenAI. Let's quickly jump onto the how OpenAI will send us to the frame, and then we will convert it to the video sticker meeting. So Sumit, is there any question in how to send participant stream into the OpenAI real-time API?
Yeah. So we'll ask audience if you have any questions so far. Yeah. Good to go now.
Yeah, good to go. So let's quickly understand how to send our OpenAI stream into the video sticker meeting. So over here, you can see response audio delta. Response audio delta is nothing but our chunks of audio. On the chunks, which is in form of bytes, we will convert that into the base64 decode format. So I have already told you about OpenAI will accept base64 encoded audio and base64 decoded audio. So we will get base64 audio, and this audio we have one more class which is audio stream tag. We have this audio stream tag. We have used use this class into the meeting configuration over here. Custom microphone audio track. So this is nothing but our audio track, which will help bot to speak anything inside the meeting. So custom audio track, we have important method over here is a receive method. So receive method is will we have to pass one frame inside the receive method, which will handle by the open WebRTC itself. So inside the receive method here, we can see that if we have inside the frame buffer is nothing but we have maintain one queue which is available frames. If there is an available frame in the frame buffer, then we will return that frame, or else in else case we will create one silent frame and then return to the meeting. So here is a frame buffer queue. We are passing our OpenAI stream into this frame buffer. Let me go through over here response delta. Okay, on audio response. On audio response, you can see that our inside our custom audio track we are adding new bytes. So add new bytes method inside the custom audio track. Inside the add new bytes, we will get audio data streams, and we are putting that into our available queue. And then we will get one by one chunk from the audio queue, and then we will convert that by 64 encoded data into our AV module frame. AV module is nothing but Python AV module. You can check out from here as well, Python AV module. So here we are using AV module audio frames available on AV. Python AV audio frame. So here is the beautiful documentation of the PyIV module. So here we have used this audio frame as well. Audio format, audio frame. Here is the audio frame. So we have to convert base64 data into the AV module audio frame. So we have built one frame based on the chunk, and we will append that audio frame into the frame buffer. And over here we are getting frame from the frame buffer queue. If there is any frame available in the frame buffer, then we will return that frame, or else we will create a silent frame. So this is done for the outgoing stream from bot to video sticker meeting. So Sumit, I would like to ask any questions.
Yeah,
Audience have any questions?
if you guys have any question, please feel free to ask.
Okay.
We can start with
Yeah, sure. So we will start our client side application on which is running on 5173 port, and we will start our Python server as well, Python main.py. So which will take around 10 to 12 seconds because of caching. Cool. Our server is running on 8000 port and our client is running on 5173. Let's quickly go over the client. I will create a new meeting with my name Ankit, and I have chosen English language. I will create a meeting. Okay, I think let me share that screen as well. Okay, cool. I will create a new meeting with my name Ankit. I will choose English language, create a meeting. I will allow my recording and media permissions. I will invite Sumit to join meeting so
Yeah.
that he will also able to translate.
I need meeting ID.
Yeah, sure. Sumit will join soon.
So I'm choosing Hindi. Huh?
Yeah, sure.
Should I choose Spanish?
Yeah, sure. If you know Spanish.
I don't know. So I'm choosing Hindi. Oh, hi.
Hey, Sumit. So let's quickly invite AI agent as well inside the meeting. Yeah,
Oh, there we
our
go.
AI agent is also joining the meeting. Let me unmute myself and speak some of the sentences. Hey, Sumit, how are you doing?
Can you check? Yeah. Can
Let me check the server side. Is there any error or not? Yes, sir. The server is running our school as well. Let me try again. Hey, can you please tell Sumit that I have assigned work?
सुमित अंकित कह रहे हैं कि वो एक
yeah, yes.
असाइनमेंट पर काम कर रहे हैं
Yeah, so I can also speak. So I'm going to speak in Hindi. So it's push to talk. So what's happening is I'm speaking Hindi, and AI agent is listening to that, and then it is doing all the processing that Ankit told, and then it is translating to a different language. So now I can speak Hindi. Hi Ankit, धन्यवाद
उन्होंने आपको धन्यवाद
for
कहा
building code.
वे कोडिंग कर रहे हैं
Yeah, it is available. Hey, Sumit, can you please tell me what I have told you yesterday and some of the tasks assigned to you?
सुमित अंकित पूछ रहे हैं कि कल उन्होंने आपसे क्या कहा था
Yeah.
और कौन-कौन से कार्य आपको सौंपे थे
So this is how it is working. Yeah, thanks,
What happened?
Ankit.
Yeah, just give me a second. There is an issue.
Actually, there was some echo, so
Yeah, sure.
we were like sitting close to each other, and because of that echo, there was some disturbance. Sorry for that.
Yeah, let's quickly run another example, another conversation as well. Hey, Sumit, can you tell me how was the movie yesterday?
सुमित अंकित पूछ रहे हैं कि कल की फिल्म कैसी थी
Yeah, actually, maybe it's because of the screen share. We are not able to listen to like AI agent voice. Yeah. So basically, this is how it is working. So if you like try it inside your, if you try it locally, it is going to work absolutely fine. So I think we also have one demo for this. We have like a video for this, so we
Okay.
can share that with you as well. There you will see like all the details on in terms of how it is working. Okay. So if you have any question, please feel free to ask. Then, okay. Yeah, thanks, Azan. Yeah, so before we end this session, thanks, Ankit. Thanks for such a nice implementation guide.
The participant's voice be
We
emulated by the AI translator. Can you submit?
Can you give us more context? Actually, I didn't get it. Hi, Alex. Yeah, you can definitely add voice clone.
Yeah.
Basically, yeah, actually, you can do that integration as well. So you can include any AI service. Yeah, that's all. Thanks, Ankit. Thanks for such a nice implementation guide.
Thank you, Sumit and team for
And
having me.
yeah, thanks everyone for joining in. And Alex, please join our Discord community if you think like if there are other questions. Okay, so let me share this GitHub repository as well.
Yeah, sure. The URLs of the community and documentation. Yeah, sure. Yeah, sure. I will share the link of documentation.
Also, we created a playlist on AI agents where we have like different use cases. So it is about game agent, vision agent, everything. So let me share that as well.
So I have shared the documentation link of the video SDK Python side and platform OpenAI API.
Yeah.
Yeah.
Thanks everyone. Thanks for joining in with React Native. Yes, you can like we provide React Native SDK, so you can also create a client, right? That is calling a server for AI agent. So we have React SDK, we have Flutter, iOS, React Native, SIP. Yes,
Yeah, sure. Tahil.
actually, SIP is a really great use case where you can build telephony agent. So with SIP, like you can call server and like how SIP work is basically we call to a number, then they uh, make a webhook request. So obviously you can build this.
On the other hand, I will also suggest like SIP is nothing but our client side replacement. Right now we are using React SDK in browser side and we are joining from the browser. In the SIP, you will join from the telephony and you will integrate all the SIP input as well from the React, our documentation itself.
Okay, so let me share something interesting with you. Is my screen visible?
Yes.
Okay, as you talked about SIP, so I think we have something interesting for you. Oops. So this is SIP flow. Like this client is a SIP user. So this SIP user is just dialing a number. Then a webhook request is made to our Python server. And then we just talked, right? We have video SDK that is managing all the participant states. So yeah,
Yeah.
we can also share that. So I think we can also create a webinar on this as well.
Yeah, sure.
Yeah, perfect. So that's all from our side. Thank you, Ankit. Thanks
Yeah.
everyone for joining
Thank
in.
you everyone. Thank you everyone for joining.